Good morning, everybody. Let's get started. Let me go ahead and share my screen. Today, we will be talking about progressive web app performance optimization and techniques. Thank you so much, Geeko, for having me here. And my name is Deepa. I'm a Google developer expert in web technologies. I am also a blogger, a content creator, and an ambassador at Women Tech Makers. Fun fact about me is I'm an avid coffee drinker. Here is a Linktree QR code for all my handles. Also note that every slide will have my LinkedIn handle at the top right. So before we start off with the agenda, I expect you to know a little bit about progressive web app, web development in general, and some performance techniques if you have already used it. And the agenda today will briefly skim through progressive web app, and we'll talk about performance. Why is it important? When do we have to start? And what are the optimization techniques that are available and the tools that are available in the market? And we'll wrap it up with a summary. So with that said, progressive web apps are websites. These are web apps developed using a number of specific technologies and standard patterns to allow them to take advantage of both web and native app features. They look and feel like a native app. Note that when I'm talking about native app, doesn't mean that it has to be mobile. It could be desktop, it could be a browser. So it could be any device specific, right? Device or OS specific too. Here's a progressive web app architecture. If you see in this architecture, you have a couple of things added to it. One is a manifest, and the other one is a service worker, which is interacting or which is constantly fetching information from the web server. So progressive web apps are a slew of new APIs, which consists of service workers, background sync, push notification, caching, file handling, file system handling, and they can also do background fetch and sync, etc. Right? So these applications are made using these new modern APIs. So service worker API, what does it do? It basically listens to fetch API requests and it loads content offline, and it can do background sync, and it enables push notification too. So we saw in the architecture, we talked about manifest. Manifest is used for rendering. This is a JSON file that tells the browser how your PWA has to behave when it's installed on a user's desktop or on a mobile device. It could have some details about what is the theme color that you're using, what is the icons, background color, name, etc. And then once you have it defined in this JSON file, you can link that JSON file inside of your HTML file as a link tag. So now let's talk about page load today. In 2023, the average page load on a desktop is about 2.5 seconds, and it's about 4 times on a mobile, according to a survey of top 100 websites done globally. So top browsers like Google strives this load time to be less than a half a second. So this is the state of web page load as of today. So according to 2023 Statistica survey, single page load on a mobile has a impact, right? It shows, as you can see from this chart, it shows that the longer the wait time, the more a user is willing to leave the website quickly unchecked. So in fact, it significantly increases around the 5-second mark. About 1/3 of them are leaving your application on a mobile browser without even checking it out. So having that said, Firefox stats show that if you can reduce your page load time by 2 seconds, it could lead to more than 15, it could result in 15% more of downloads. So that becomes very important to reduce your page load somehow. And we'll talk about those techniques. And according to Bing stats, any 2-second delay would result, if your page is 2-second delayed in loading stuff, it takes about, what happens is that you could lose your revenue for about 4% per user. Imagine millions of users are visiting your page and your page is not loading up. And as a result, you are going to lose about 4% of your revenue per user. And this would add up to a lot of money, right? So that's why performance is directly related to money, and your speed and speed of your application matters a lot here. So having said this, how do you, what does it, why is it why now we know performance leads to speed, your speed leads to money, right? It increases retention, it increases conversion. So that becomes a top priority, so that you can have conversion rates, and your users could, you can achieve that only by offering your users an excellent and consistent experience. So that becomes more and more important. So basically, I know at the end, web performance triumphs over a designer or a developer happiness, and it's more important than using a latest framework, or it has to do with the conversion rates too, right? So it's important. So what influences performance, right? So for example, if you have a request and response and your information gets parsed, it gets executed, right? So when you are developing a application, for example, you're using a new library, right? Which it could lead to a bigger bundle size, and bigger bundle size means bigger download. Bigger download would lead to longer parsing time and longer execution time. So these are some of the things that influences your performance. So having said that, where do we start performance, right? We need to start performance at the foundation level. So when you're even planning out, you think about hosting. Where do I host it? How is there a way that I could deliver the content through network? And if you are an existing web application, if you already have an existing web application, if you are planning to convert it to PWA, think of progressive enhancement, right? And also think at the design level. What content you want to have, and how it can be laid out. What are the images, audio, media formats that you're going to use, and how do you compress them, or how do you have them on your page? And other libraries like fonts, material UI icons, icon libraries, third parties such as maps and social. All those things, if you think ahead of time, or while developing during these things, have these things at the back of your mind too, right? When you're developing, you can think about, how do we cache these stuff, right? Can I do image markup? Can I do lazy load of images? Can I add, how about think about scripts and styling, whether you can minify the JavaScript file, what kind of CSS framework you're going to use. All those things matters when you are thinking about performance of your application. So how do we measure performance? There are metrics to measure your performance of your application. Some of them are like I listed here, time to first byte, which is nothing but a time that takes between a click of a link and the first bit of the content showing up on your web page, right? And the first contentful paint is something that when the when the user requested a content and when it becomes available, right? That's one thing. And there's something called as interaction to next page, which assesses whether a page is responding consistently fast to user inputs. Imagine you're trying to fill in a form and it responds to it consistently fast, right? And total blocking time, it calculates the uh, amount of time the main thread was blocked during a page load. So if you have a main thread, and when you have a main thread that goes on, and then if it is blocked during page load, what happens, right? How long does it take to recover from it? And there's also something called as largest contentful paint first input delay, and there's something called as time to interact. How long does the user take time? User takes time to interact with that page. So all those things are measure of metrics of your performance, and these are measured in milliseconds. So we talked about the measures. How do we measure it? But are there tools that are available to measure the performance? Yes, we do have it. There are tools like Website Grader, Lighthouse, Chrome DevTools, etc. Right? Let's talk about Website Grader. Here's an example of Pinterest website performance using Website Grader. Apart from performance, SEO, search engine optimization, mobile, and security, Grader also gives you information about page size, speed, and image size too, right? And the next tool is Lighthouse Audit. It is a Chrome extension where you can run audit on your pages based on these categories such as performance, accessibility, best practices, search engine optimization, and progressive web app. So note that you can analyze here for both mobile and desktop too. And this is the same Pinterest website that I picked up and then ran a performance score on that. So the performance does vary on the time of the day that you analyze these pages, and of course the bandwidth, the network bandwidth that you had at that point of time. So it could vary from tool to tool. So the next one is Chrome DevTool. If you go to Chrome DevTool Performance tab, it'll give you may see a detailed information of the same. This is again from Pinterest website, and it gives you in great detail, such as how long did it take for scripting, how long did it take for rendering the page, and the paint, how long did the painting of the content take. So all these measures it does give from frame to frame. So based on that, you can improve your performance too. The next one is Performance Insights. This is still an experimentation. You can record a page load and see the performance information. You can also replay to see where improvements can be made. It also gives those metrics we talked about, such as first and largest contentful paint as well. Now, let's switch gears and talk about optimization technique. There, we will be talking about caching, code splitting, lazy loading, minify, and compress resources, and other techniques too. Note that there's no one way, there's more than one way to do this. So, well, first we'll move on to caching. So caching has, you can use caching in different ways in progressive web app. You can cache first with refresh, network first, index to DB, which is a low level API. And you can also use server side rendering. So for cache first, if you see here in this code snippet, if you see the variable which contains pre-cache resources, and here it takes an array, I can put in what are the files that needs to be cached when the when the page is reloaded or when the user visits the page, right? And it also, the service worker, note that all these functions go inside the service worker file, and it listens to any user event, and then it loads based on what is there in the pre-cache. So here's the async function, and it checks whether the cache response matches the current request. If not, it will fetch the new thing and then replace it with the old one. So the next one is cache first with refresh. Note that here we are not using JSON files. So when the user visits the same page and they're just refreshing it, you don't need to cache the entire JSON file, right? So we don't want to do that. We just want to see whether what's the request that came in and then what's the response. If the response is going to be the same, we just pull it up from the cache. Fetch it up from the cache. This is what this code snippet means. And the next one is network first response. Again, it looks for the network request that the user has requested. And if there's any new information, it fetches it. Otherwise, it'll get it from the previous cache itself. The next option that we have here is caching using indexed DB. For more complex data caching and storage needs, PWAs can use indexed DB, which is a low-level API for storing structured data, including large amounts of structured text, images, or binary data too. So this is a method of storing data on client side. However, this API is not available or may not be available on new browsers or very old browsers. Although it says in this, I picked this from caniuse.com. It supports most of the browsers. If you can see, most of them are green, but it's good idea. It is a good idea to check on your code whether your browser supports this API first. So when you add a function, make sure that this is something that's available. If not, you can handle the error handling too. Next comes server-side caching. Cache the pre-rendered HTML on the server side to serve quickly to subsequent requests using either Redis or Memcache. These are popular tools that are available, and frameworks such as Next.js and Nuxt.js, because Next.js is a side. It's a framework for React. On the server side rendering, and Vue is, again, if you have an application already in Vue and you're trying to make it as a progressive web app and you want a server side caching framework, then you could use either Nuxt in that case. And the next technique we are going to be talking about is code splitting. Code splitting is nothing but you're splitting up your JavaScript files into smaller bundles. And you can, by doing this, you're making it into a manageable piece of chunks, so it is available on demand whenever there is a need for the page to show those content. So the popular tool that is used here is Webpack. As you can see, it can bundle your assets, your images, and other resources too. So that's one way. And code splitting can be done in two ways. One is module level. Here is a example of React. In React that I'm using, I'm using a import function to dynamically import a module called dynamic module, and this module will load asynchronously when needed, rather than being bundled with your main application code. Right inside the use effect, if you see, we are triggering the dynamic module load when the component mounts. So in the return statement, you also see that we conditionally render the dynamic module data based on whether it has been loaded yet or not. So this is one way of splitting your code. This is module code splitting. The next one is route-based Code splitting. Route based can be done for each route. For example, here's a React code for homepage and about page. You could do code splitting through based on your routes too. And the next next technique we'll be talking about is lazy loading. And lazy loading is nothing but we know it is by deferring the loading of non-essential resources, right? When you want to load only very specific essential ones, and the rest of the ones that you don't want it to load right away, this way you can reduce the initial page load time. So you could add this inside of a script tag inside your HTML. As you can see, here is a function where this function, this function loads all the images, lazy loads all the image data sets in this inside the script tag. And the next one we will be talking about is minify and compress. For JavaScript and CSS compression, you can, when you use these tools like Webpack, Cursor, or CSS Nano, what these tools do is they remove the comments, white spaces, and then they compress the file size. So that's one thing. And because of the size, the page size, the file sizes are smaller, the page will load faster. And you could also compress images using tools like ImageMagick or OptiPNG. And then for file compression, you could use gzip on the server side. And note that when you update anything on, when you minify or compress any files, you need to update it on the server side, on the service worker side. And other techniques we will be using, you could use you could use to improve the performance, or using content delivery network so that it's closer to your user. And whenever you place content that is available on the cloud, and the users and it's placed near the user's location in the globe, it's easier to fetch information, right? And progressive enhancement, build your progressive web app in layers with basic functionality available even without JavaScript, and then enhance the experience for users with JavaScript enabled devices. This approach ensures accessibility and resilience too. So you can optimize images. We talked about optimizers that are available. You could also use different formats too. And load balancing is another technique. Consider load balancing to distribute the load evenly when you have traffic. And this way, when you, it could prevent performance bottlenecks too. So to summarize, there are a lot more approaches. This I picked it up from one of the online, and this is for web performance per se. As you can see, there are so many ways to do this, and with new things coming up every day, new tools, new libraries, new frameworks coming up, there are a lot more. You could pick and choose for your application. And I also wanted to mention that there were a couple of case studies here. Cellco and Workwear Express, they made some performance optimization to their websites, and they saw that there's an increase in revenue and conversions and transactions on their websites. And the second one, this one was one of my favorites because it talks about optimizing the performance of a React web app, React PWA. And this particular company used strategies. It's a very detailed read. You can look into it in Medium, and it talks about how did they optimize their bundle sizes using bundle analyzer and stuff. So it's a very good read if you want to take a look at it. And with that said, progressive web apps are meant to be reliable, meaning that they load fast, they work offline, they are fast and engaging with you with consistent UI, and they are also responsive to all layouts, right? So performance optimization directly relates to user experience. More money is, you could get more money and better discoverability. And with that said, thank you so much for your time. And thank you so much, Geekle, for this opportunity. I hope this session was useful. Please do connect with me. And if you have any questions, reach out to me either in Slack or in LinkedIn. Thank you once again. I'm going to leave the screen for a second so that you can scan my QR code here. Thanks a lot.